Hello and welcome back to my channel. Today on the bench I have a small charger from a small electric vehicle, if I'm not mistaken some kind of ATV. The owner told me it stopped working and he asked me to take a look at it. 36 volts and 1.5 amps. No LED. Do I have any output? No. Let's open it up. The warranty seal is still intact. That's a good thing. It means that no one else has opened it up. Pretty basic, right? A small flyback power supply. How do I know it is flyback? Well, it has only one MOSFET in the primary side, and on the output there is no inductance, so it must be flyback. This must be the controller on the secondary side for the constant current. No, it is just an op-amp. 4 op-amps in one SOT 14 case. As I said, pretty basic, but it does the job. And this must be the controller from the primary side. Q8, right? We will see under the microscope. So let's see, do I have a fuse? No, I don't. I didn't even need to measure it. No, it looks blown. Of course it is. What does that tells us? Well, the MOSFET must be blown up. It is the only reason the fuse would blow up. Granted, there could be a blown up diode bridge rectifier. It could also trip the fuse, because a blown out bridge rectifier would mean AC on the main capacitor in the primary side, and that would short up the mains. But most of the time the MOSFET gives out. So let's see. Am I right? Yes. The MOSFET, it is shorted. Sorry, the MOSFET is shorted. Not it is. How about the bridge rectifier? This is the minus side. Shorted. Shorted. Really? Shorted all the way. Jeez. The fuse was supposed to blow up before the semiconductor, before the bridge rectifier, but it didn't. Do I have a shorted gate on the MOSFET? Yes. Then the controller is also dead. I have set up my microscope because we need it. And how do I know that the controller is dead? Well, when you have a shorted gate on the MOSFET, all that high voltage, 300 and what, 20, 30 volts, is fed back to the controller's output, and that means the controller is dead. We can check. First, we check the diode. There is a diode in series with the controller in the reverse polarity. This diode makes it possible for a faster turn off for the MOSFET. It isn't shorted because it is in parallel with this resistor. And it should be 10 ohms. Yes, it is. How do I check that the controller is dead? Well, first we need to identify the power pins, the supply pins for the controller, and there is a small capacitor here near it, and this is its minus side, and this is its plus. So minus, minus, plus. So here is the plus side, and I'm guessing here is the minus side. So we check it on the diode function. We measure the output with respect to the supply pins. If the controller has its output shorted, then we should see a short either to the minus side or to the plus side. And look, it is shorted. A good controller must have here a diode, because this output is a totem pole output, and when the controller is good, you measure the reverse diode on those MOSFETs. So I have a QBX controller, SWAT 236. Before I check for the replacement parts, I need to measure the current shunt resistor from the primary side. Because the MOSFET is shorted, most likely the shunt is also shorted, blown up. I am using this analyzer, and from the colors it should be 510 milliohms, right? Let's see. It is. So the current shunt resistor is safe, is intact. Good. Then all I need to do, let's check the capacitor. The mains filter capacitor. First, I need to make sure it is discharged. So Is it dead? Seems to be, right? How about this small one? 10 microfarads. Also dead? Really? This looks like it is okay. Should be what, 220 microfarads, right? Yes, 220. $63 volts, 220 microfarads. I'm guessing these ones measured badly because there is shorts on the board and those confuse this tester, but I will take them out and test them that way. I have my replacement MOSFET and controller. The MOSFET is a 8N65, 7.5 amps and 650 volts. The original is a 5 amp and 650 volts. Also, the original has a 2 ohms RDS on. This one has about an ohm, so it's better both on the current and on the RDS on. And the controller is this one, ME8204BM6G. QBX. But before that, let's take out the capacitors and test them again. So let's see. "41 microfarads, about, well, 500 milliohms. 47 microfarads, so it is okay. "10 microfarads. This one is also good. I have my replacement fuse, and I will use a bit of heat shrink on it. I need to trim it a bit. I have all my replacement parts here ready to go, so let's get to work. First, the controller. I am using my smallest tip I have. And some 0.25mm solder wire. The thinner it is, the better job you do. I am using a slightly bigger bridge rectifier just to make sure it doesn't short out before the fuse blows. And this time 0.5mm solder wire. For the rest of the components, I am using my 3mm straight tip and 1mm solder wire. First, the MOSFET. Never throw away these leftover wires. You never know when we might need them. Right, all the components are back in their place. Now let's give the board a bit of a clean. So everything is in its place. I did clean up the board. Let's test it, shall we? Yes, I do have my LED. What about my output? 41 volts. I'm guessing this is a no load voltage. So yeah, this should be it. I need to make sure the charger does work as it's supposed to. So I did solder these wire taps here. As I told you, never throw them away. And I'm using my electronic load to connect it to these wire taps. So I will start at 1 amp and go from there 100 milliamps at a time. The no load voltage 41.4. Let's see. Let's start the 1 amp test. 44, 1.1, 1.2, 1.3, 1.4, and finally 1.5 amps. It didn't like that. It got into the continuous current mode, and the electronic load doesn't like that. Anyway, it does what it's supposed to. So job done. The board is back in its place. And I'm guessing it is intended for a string of 10 series cells. So the voltage should be okay. Let's power it up again to make sure it still works. Yes, it does. So this is my repair video. If you watched it until the end, thank you. If you like my channel, please subscribe, give it a big thumbs up, and other YouTube stuff. It always helps with the algorithm. If you want, you can become a member of my channel. If you want to support me, you can buy super thanks. So I will not bore you any longer. Thanks for watching and see you next time. Bye.